Hello there. It's me again, David Haywood, your stats professor here at College of the Sequoias. In this lecture, we're going to go over 1.2, section 1.2, which is about visualizing categorical data with bar graphs. One of the topics that we discussed in section 1.1 was the difference between categorical and numerical variables in data. So we're going to talk about visualizing categorical data in this section, and we'll talk about visualizing numerical data in section 1.3 in the next section. To get the most out of this lecture, please be sure that you have either printed or downloaded the notes so that you can take notes as we move through the examples. And then also make sure to download the Excel spreadsheet that's called Data for 1.2. It should be with the video on Canvas. So download that so that you can work out the examples with me as I walk through them with you. And so without further ado, let's go over to the notes and I'll walk you through section 1.2. Okay. So, as I said, 1.2 is about visualizing categorical data. When we first obtain data, they're not going to have been summarized in any way, and we call that raw data. Okay, and so one of our goals in this chapter is to take a set of raw data and organize it into charts and graphs that are easier to understand. So, for example, a physical therapist wants to get a sense for the type of rehabilitation required by her patients. So to do so, she obtains a simple random sample of 30 of her patients and records the body part requiring rehabilitation. This would be something like the raw data that she would collect. Okay? So you can see it's just a list. It's just a list of the body parts requiring rehabilitation. It hasn't been summarized or organized in any way. It's just sort of a random list. Now here we have a summary of the data. We have categorized things by the location of the injury and then counted up the number of times that that particular body part required rehabilitation. And you can see that this is a much nicer way to look at the data because you can tell right away, for example, that back injuries were the most common, right? And you can just get overall a better sense for the types of injuries that this particular physical therapist treats more regularly than others. This chart here is called a frequency distribution or a frequency table. So let's talk about those in a little bit more detail. So the frequency of an observation is the number of times that it occurred in the sample, and the relative frequency, or I might sometimes use the word proportion, is the fraction of times that it occurred. Okay? So we can see, going back up to the previous example, that the number of back injuries that this, out of the 30 patients, right, the number of back injuries that this physical therapist saw in her sample was 12, right? There were 4 shoulder injuries and 2 hip injuries and so forth, right? So those are all frequencies. The proportions would be if we took each of these numbers and divided by the total number of patients in her sample, which was 30, right? So the proportion or relative frequency of back injuries would be 12 out of 30, right? 12 divided by 30. We'll look at that in a little bit more detail. In general, we'll use the symbol, this symbol right here, which we read p hat, to represent the sample proportion of a particular kind of injury. And the way you would calculate p hat is you would say p hat equals x divided by n. Note that a proportion is just a percentage expressed as a decimal, right? So if you had a sample proportion of 0.27, that is equivalent to saying 27%, okay? So referring back to the physical therapist's data above, what was the frequency of shoulder injuries and what about knee injuries? So I'll let you pause the video and see if you can answer those questions. I'm going to go ahead and give my answer now. So the frequency of shoulder injuries looks like it was 4, okay? And for knee injuries, it looks like it was 5. So for shoulder injuries, the frequency was 4. And for knee injuries, the frequency was 5. Okay, part B. What was the proportion / percentage of shoulder injuries, and what about knee injuries? Okay, so for the shoulder, the proportion would be 4 out of 30. Okay, and we can just change that to a decimal. We can use our calculator or something to change that into a decimal. So let's do that real quick. I'm going to go ahead and go to Desmos. And if you go to desmos.com and then open up their scientific calculator, I think this is a really nice calculator that I'll use throughout the semester. But we want to do 4 divided by 30. So I can just type in 4 and then the fraction bar on my calculator, the division sign on my keyboard, and then 30. And there's the relative frequency, in other words, the proportion, in other words, the percentage. Okay, so there it is. Okay, so 4 out of 30. Oh, I forgot what the answer was. 4 out of 30 was 0.1333. Okay, so let's write that down. Let's go to 3 decimal places. So this would be 0.133 as a decimal. If I wanted to give it as a percentage, I would call it 13.3%. Okay, we just move the decimal 2 times. As for the knee injuries, right, we would do something similar. We would say for knee injuries, this would be 5 out of 30. Okay, and I believe that that is approximately 0.167. You can type that into your calculator to verify if what I'm telling you there is true. And as a percentage, we would call that 16.7%. Okay, so these are the proportions, right? P hat. This is P hat for the shoulder and P hat for the knee. So sometimes we might use little subscripts to distinguish between different proportions. But that's that. Okay. Moving on. A frequency distribution or frequency table is a table that lists each category of data together with its frequency. A relative frequency distribution is a table that lists each category of data together with its proportion or relative frequency. Okay? So we've seen this chart before, right? And as I said, it's a frequency distribution because it's listing off the location of injury and then counting up the number of times that those injuries occurred. Okay? This is a relative frequency because it's taking each of those frequencies and dividing them by the total. So it's giving us a proportion, right? It's giving us the proportion or the percentage of times that we saw injuries in each of those locations. Okay, so obviously we can make these kinds of charts by hand. We could comb through our raw data and manually count up the number of times that a particular observation occurs. However, we're human beings and we're not very good at that kind of thing. Machines are much better at doing this. Computers are much better at doing this kind of thing. We as human beings, we tend to make mistakes on monotonous tasks like this. And besides that, imagine if you had, in this case that we've been looking at with the location of injury example, there were only 30 individuals in the sample. So that's not a very large sample size. But you can imagine a case where you might have 100 individuals or 1,000 or maybe millions of individuals in your sample, and in that case you're really not going to want to go through and count up these frequencies by hand. So let's learn how to do this in Excel. I have on Canvas an Excel stats procedures. I'm calling it a handbook here. Really, it's just a little. It's a little Word document that has step-by-step examples along with videos. Okay, tutorial videos to show you how to do each of these things. So, so in the future, if you're coming back to this and you're trying to figure out how to, make some kind of frequency table, and you don't want to rewatch this entire lecture just to get to that part, well, you can just watch that video from the Excel stats procedures worksheet, Word document. But anyway, I'm going to take you through a couple examples here during the lecture to show you how we do this. So this first example says, the data below represent the responses of 18 people who were asked what their favorite fruit was. Right? So the first person said orange. Oh, actually, it looks like they've just been organized. But anyway, there were a few people who said orange, banana, right, apple. These were their responses. We are asked to use Excel to organize this raw data, right? This stuff up here is raw data. And we're being asked to use Excel to organize the raw data into frequency and relative frequency distributions. So at the end of the day, we want something that looks like this for a frequency distribution, and this for a relative frequency distribution. Let's see if we can get Excel to do this for us. So heading over to Excel. So here's the data. The way that we're going to organize this into a frequency distribution in Excel is by using pivot tables. So to insert a pivot table, first we need to select the data. Now in this case it's not hard, we just click and drag, okay, to select the data. If we had a lot of data, like if this were 200 rows long or something, then another way you could do the same thing is to hold down Control, Shift, and then the down arrow, and that will select all of the data for you. Okay, so we've got our data selected. Now I'm going to go to Insert up here, and I'm going to click on Pivot Table. Excel has the favorite fruit column listed as the range of values that we want to make our pivot table out of, and that's correct, so we'll leave that as is. We need to choose a place to store our pivot table. We can either have it stored in a new worksheet, so it'll open up a new tab down here, right, and put the pivot table there. I don't want to do that though. I'm just going to store it in the worksheet that I'm currently working in, so I'm going to click that button, existing worksheet, and then I have to tell it, well, where in the worksheet do you want to store it? Do I want to store it down here or up here? I'm going to put it right here, so I'm just going to click on this cell, and that will tell Excel where to store the pivot table. And then we're going to say OK. From here, what I'll do is I'll take this favorite fruit column and I'll drag it down to rows. And you see what that does is Excel will automatically group the responses into these categories, right? Apple, banana, orange. To get Excel to count up how many people answered apple or banana or orange or whatever, I'm going to take the favorite fruit and this time I'm going to drag it down to the values box. Okay, and now it has counted up the number of people who said apple and banana and so forth. So we can see clearly that 2 people answered pineapple, right? And 3 people answered orange. Again, that might not seem like a big deal given that we had such a small data set to begin with, but imagine if you had 1,000 responses in your data set. Excel will do this for us in a blink of an eye, which is really nice. Okay, so there's our frequency distribution. We were also asked for a relative frequency distribution, so let's go through this process again. Okay, so first I'm going to start by selecting the data that I want to make a table out of. Okay, I can do that by holding down Control, Shift, and then the down arrow, and then going to Insert, Pivot Table. Let's go ahead and store this pivot table right underneath the first one. So I'm going to click on Existing Worksheet and then click on that cell. And then I'm going to build my pivot table by dragging the favorite fruit variable down to the rows box and then down to the values box. Now this is giving me a frequency distribution. I want a relative frequency distribution. So what I'll do now is in the values box, I'm going to click on this little arrow next to the count of favorite fruit, and I'm going to click on value field settings. Okay. And now here in this dialog box that opens up, I want to click on show values as, and then where it says no calculation, I want to click on that drop down menu, and I want to change it to % of column total. So instead of not performing any calculation, now what it's going to do is compute the percentage of the total. So it's going to divide each of these by 16, which is what I want it to do. So I'll hit OK, and then it changes my frequency distribution into a relative frequency distribution just like I wanted. And now this matches more or less what was on the notes, right? Okay, so that's how we make frequency and relative frequency distributions out of qualitative data or categorical data. Having done that, then the next thing that we usually want to do is to make some kind of graph out of it, some kind of visualization. And the best visualization for categorical data is the bar graph. Okay, there are other kinds of visualizations that we'll talk about in future sections, but for now let's focus on the bar graph. We've all seen these before, I'm sure. So each bar represents, going back to the location of injury example, each bar would represent one of the locations, and those bars would be drawn going up to either the frequency or the relative frequency, depending on what kind of bar graph you want to draw. And again, you know, we could do these by hand if we wanted to, but Excel is going to do a much neater job and a much quicker job, and so we'll just use Excel. So let's use Excel to produce the bar graphs for the fruit example we were just looking at a second ago. Let's try to get a frequency bar graph as well as a relative frequency bar graph. So let's head back over to Excel and see what we can accomplish here. So we've got our frequency distributions already, our frequency and relative frequency distributions rather. If I want to make a bar graph out of these, I can select one of these tables, okay, and then go to Insert. And here I have a couple of options. I can either go to Recommended Charts, and then it'll probably recommend a nice looking chart, or I can be more, I can take more control, I guess, of the situation and tell it what chart I want it to insert. In this case, I want a bar chart, so I can go to this thing that looks like a bar chart. Not this one. This is a histogram. We'll talk about that later. But I can have it insert a bar chart. And then I have more control over whether I draw the bars vertically or horizontally or whatever. Most of the time I'll choose a vertical orientation. And that's basically it. This doesn't look quite like the bar chart that was in the notes. I think in order to get it to look like the notes, for one thing, we don't really need this legend. This thing would be useful if we had multiple groups that we were trying to compare, because then the different colors would tell us which groups or which bars represent which groups. But we don't have multiple groups here. I'm just going to delete that. So I'm going to select it, and then on my keyboard I'm going to hit delete, and that gets rid of that. Another thing I want to do is probably change the title of the graph. I don't want it to say total. Maybe I want this to be fruit preference. So I can just click that and change the title. Another thing I might want to do is add labels to my X and Y axes. The way I'm going to do that is by clicking on this plus sign right here. And this gives me the option to add a whole bunch of things. I can add axis titles, so now I can change the titles of these axes. Another thing that I can do is add data labels, which is really nice. Okay, let me change these axis titles. So these are fruits, right? So I'm just going to call this axis fruit. And this is, these are the frequencies. Okay, so I'm going to change this axis title to frequency. Okay, I can make this look even better. I think there's a way to hide these. If I right click it, I can say hide value filled buttons on chart. Right, I can do the same thing here. Hide axis filled buttons. Okay, and now it's starting to look really pretty nice. So there's my frequency bar chart. I can do the same thing, of course, for the relative frequency bar chart. I would just select this one and insert a bar chart. And now instead of displaying the frequencies on the y-axis, it's displaying the percentages or relative frequencies or proportions, whatever you want to call them, on the y-axis. But everything else is the same. I could go through the same steps to kind of make this look a little bit better if I wanted to. I could show the data labels and get the percentages up there. I could add axis titles, right? So this is still fruit. Whoop! This is still fruit. And this is still, or this is now relative frequency or proportion. I can change this to fruit preference. And now I've got a pretty nice looking graph at this point. One thing that I failed to mention on the previous one is if you click on the paintbrush, then you can change the style, you can change the color, different color palettes, right? So, you know, you're welcome to kind of have fun with this and just, that one actually looks really kind of nice, right? Anyway, oh, except for these labels get messed up. But anyway, you're welcome to kind of play with this and create different kinds of charts. But that's how that would work, okay? So, moving forward, at this point in the course, I'm not really going to talk about, well, actually that's not true. I was going to say I'm not going to talk about creating side-by-side bar graphs, but actually we will. We will talk about creating some side-by-side bar graphs in a second. But for now, I just want to focus on interpreting these and making sure that we understand what's going on with this graph. This is a case where we do have multiple bars, and so we have a little legend up here that tells us which bar represents which group of people. Now, unfortunately, I printed this in grayscale, so it's hard to tell which bars represent which, but if you open up the notes on Canvas, you'll be able to see a color picture of this, and so then it'll be more clear. But in this case, this bar on the leftmost side of each group, of each age group, represents more likely. More likely, okay? The bars in the middle represent less likely, and then the small little bars, they represent neither. Let's read the scenario, okay? This is supposed to represent a random sample of 2,163 adults aged 18 or over. They were asked when you see an ad emphasizing that a product is made in America, are you more likely to buy it, less likely to buy it, or neither? And these are the results. Okay, so we can answer all kinds of questions about this. Notice that this is a relative frequency distribution. We would call this a side-by-side bar chart because we're comparing multiple different groups across multiple different responses, right, in side-by-side bars. Anyway, part A asks, what proportion of 18 to 34-year-old respondents are more likely to buy when made in America? What about for 35 to 44-year-olds? Okay, so for the 18 to 34-year-olds, we're looking at this group right here, this age group, 18 to 34. And we're asked, what proportion of them are more likely to buy when made in America? Well, that's given by the leftmost bar. Okay, so what proportion? It looks like about 0.45 is the proportion or relative frequency, or you could call it 45%. Okay, so I'm going to say, well, okay, so P hat for, we'll just call these 18-year-olds, so I'll call it P hat sub 18. That would be, let me use an approximation sign because I think it's not exactly 100% clear, but I think it's approximately 0.45 or 45%. Okay. For the 35 to 44-year-olds, that proportion would be closer to probably like 61% is what it looks like. So P hat sub 35 is a little closer to 61%. Okay, part B asks, which group has the greatest proportion who are more likely to buy when made in America? Well, looking at the graph, these bars get progressively larger as the age group increases. So it's pretty clear that the 55 plus age group, they're the ones who have the greatest proportion of people who are more likely to buy if the product is made in America. So we would say the 55 plus, right? They're the group who has the greatest proportion of people who are more likely to buy when made in America. Part C, which age group has a majority of respondents who are less likely to buy when made in America? Okay, so this is a word that we need to discuss, right? Majority means more than 50%. Okay? So we're asking which group has a majority of respondents who are less likely to buy when made in America, and that would be the 18 to 34-year-olds, right? Notice that the proportion of 18 to 34-year-olds who are less likely to buy when the product is made in America is just over 50%, so it's just a slight majority. The rest of the groups, that bar shrinks as we increase in age, right? So they're the only group. It would be the 18 to 34-year-olds. Okay, and then finally, what is the apparent association between age and likelihood to buy when made in America? Well, we've kind of talked about this already, right? But it looks like as you look at the age groups, as you increase in age, a person is more likely to purchase an item if it's made in America the older they get. And they're less likely to purchase an item if it's made in America. The percentage of people who are less likely to buy if it's made in America decreases with age, right? So they're more likely to buy. The percentage who are more likely to buy if it's made in America increases with age, and the percentage who are less likely to buy when made in America decreases with age. So that's the association. Maybe we could summarize it like this. The older you are, the more likely you are to to view, well, let's say it, the more likely you are to purchase items made in America. Okay. So that's a pretty decent summary of the relationship between those variables, I would say. Okay, moving on. We'll do one more example. I want to show you how we would take care of a situation in which you were given a frequency distribution and asked to come up with a relative frequency distribution. Okay, I've already shown you how to make a frequency or a relative frequency table from raw data, but notice that in this case we already have a frequency distribution and we're asked in part A to make a relative frequency distribution. So let's talk about how to do that. First of all, in this scenario, the data represent the educational attainment in 1990 and 2023 of adults 25 years and older who are residents of the United States. The data are in thousands, okay? So when you see 39,344, that really represents, you really have to add 3 zeros to the end of that, right? So that really represents 39,344,000. But okay. Let's do this. Let's construct a relative frequency distribution, and then we can draw a side-by-side relative frequency bar graph, and then we'll answer the questions that follow that. Okay? So heading back over to Excel. This data set is found here in the Education tab, so I'm going to switch tabs over to the Education tab. Okay. So in order to get a relative frequency distribution out of this, which is what I was asked for in part A, right? We first will select this table, and then we'll go to Insert, Pivot Table, just like before. Just like before, we need to tell Excel where we want to store the pivot table. Again, I'm just going to store it here in the worksheet I'm already working with. Okay, now here I want educational attainment. I want that to be my rows. Okay, so I'm going to drag that down to rows. And then I want to count up the number of people who got an associate's degree or a bachelor's degree or whatever from both years 1990 and 2013. So I'm going to drag both of those down to the values box. And now here I don't want them to count these or to add them up or whatever weird thing they're doing. What I want Excel to do is to give me relative frequencies, right? So I want them to calculate proportions. So I'm going to come over here to sum of 1990. I'm going to go to value field settings. Okay, I'm going to go to show values as, and I'm going to have it calculate the percent of column total. I don't want it to do the percent of grand total. I just want it to do the percentage of the 1990 column. And so now you can see that it's giving me these relative frequencies or proportions or percentages, whatever term you prefer to use there. I can do the same thing for the other columns, so I need to come to sum of 2013. Oh, I'm not sure why it says 2013 when it should say 2023, right? But value field settings, show values as, percent of column total, and now I've got a nice relative frequency distribution. The next thing that I was asked to do was to create a side-by-side bar graph. So I'm going to select this chart. I'm going to go to Insert, and again, under Recommended Charts, usually it'll give you a nice suggestion. But you can also brute force it by saying, no, I definitely want this chart, or maybe I want to draw the bars horizontally, or whatever the case may be. But I'm going to go ahead and just put in the vertical version. Okay, and that's that, right? That's it. I can make this a little bigger so it's easier to see. And of course I can add titles and stuff. Maybe I want to get rid of these buttons, so hide all field buttons from the chart. I'll add a title, chart title, axis title. So we can talk about educational attainment in 1990 versus 2023. We can change this. This is level of education. Okay, and this is the relative frequency. Or percentage or proportional. I definitely do not want to delete these now, okay? Because these are giving me good information about which bar represents which group, right? The blue bars represent the data from 1990, and the orange represent the bars from 2023. Even though it says 2013, it should say 2023. Okay, so that's parts A and B. Now what else are we supposed to do? We're asked some follow-up questions. Part C, did the frequency of people who earned a bachelor's degree rise or fall from 1990 to 2023? What about the proportion of people who earned a bachelor's degree? Okay, well, let's take a look. Looking at the frequency distribution, we can answer the first part. Did the frequency of people who earned a bachelor's degree rise or fall? So earned a bachelor's degree, that's this group right here. And from 1990 to 2023, yeah, it doubled, right? It doubled, so it definitely rose. So the frequency rose. And if you want to give more detail, you can, right? It rose from 20,833. Actually, this is in millions, right? So from that to 41,575,000. Okay, so it rose pretty dramatically. Okay, what about the relative frequency? Well, for that, let's take a look at our table here in Excel. We want to compare the percentage of people who attained a bachelor's degree in 1990 to the percentage who attained a bachelor's degree in 2023. And it looks like that percentage also rose. If we want, we can maybe put data labels on there so we can see exactly how much it rose. So it rose from 13.1% to about 20.1%. Okay, so let's write that down. So the relative frequency, or the proportion, also rose. Ooh, let's see. Let's try again. Okay. I'm just trying to see this chart at the same time. Okay. So it looks like for the bachelor's degree, yeah, it rose from 13.1% to 20.1%, approximately. Right? I'm doing a little bit of rounding there. Okay. Part D. Did the frequency of people who had some college rise or fall from 1990 to 2023? What about the proportion of people who had some college? Okay, so a similar question, right? So similar question, looking at the frequency table, the proportion or the frequency of people who had some college, well, that also rose from about 29,780,000 to 34,805,000. So again, the frequency rose. Okay, but what about the relative frequency? Let's take a look at this. So looking at the relative frequency, we're looking for the relative or the proportion of people who had some college. Oh, by the way, I failed to mention, you can rearrange these. Notice how I think it put these in alphabetical order, but that's not really the order that we want them in. These would be ordinal data, and I think that not a high school graduate would be considered like the lowest level of education. And following that, we would have someone with a high school diploma. The way I'm doing this is I'll highlight the row, and then I'll put my cursor right on the boundary, and then I can click it and drag it to wherever I want it to go. Okay. From there, I think some college would go next, and then associate's degree, then bachelor's degree, then graduate degree. Okay, so this looks a little bit better. Anyway, so let's look at the proportion of people who had some college. In 1990, that was 18.7%. In 2023, that had dropped to 16.8%. So no, that the relative frequency dropped. Okay, let's write that down. So the frequency rose, but the proportion dropped, right? From about 18%, well, like 18.7% to 16.8%, from 18.7% to 16.8%. Okay, that's interesting. So the frequency rose from 29,780,000 to 34,805,000, but the proportion dropped. So then part E asks a follow-up question to that. It says, based on your answers to part D, is it better to compare frequencies or proportions in this case, and why? So it really kind of depends on it depends on what questions you're trying to answer, right? I would say, generally speaking, it's probably better to compare the proportions in this case, because it's true that in absolute terms the frequency rose, but the entire population has also grown in the last 30 or so years. And so what we really want to know is not necessarily how many people attained a certain level of education, but rather what percentage or what proportion of people obtained a certain level of education. And so for that, obviously, comparing proportions is going to be better. Another way to say that is that there are just more people in 2023 across the board than there were in 1990. So it's not necessarily a surprise when the numbers in the 2023 column are bigger than the numbers in the 1990 column. That's what you would expect just from population growth. It doesn't really necessarily tell you if the quality of education has somehow changed in the country during the last 30 years. In order to know if the quality of education has changed, you would compare proportions, right? You would want to see, okay, so I understand that now there are 330 million Americans as opposed to 250 million Americans, but that's probably an exaggeration, by the way. But like, I understand the population has grown, but how has the educational background of people changed? To get that, you would look at proportions. Okay, so I've said the same thing several times now. Let's just write out an answer. I think it would be better to compare proportions, because the entire population increased from 1990 to 2023. Therefore, it's not surprising that is not how you spell surprise, huh? It's not surprising when a value in the 2023 column is larger than the corresponding value in 1990. Basically, anytime you're comparing two groups of different sizes, it's better to compare their proportions than it is to compare their frequencies. The one exception to this is if you're trying to talk about like the need for increased funding or something, right? Like if you're talking about at COS, like, hey, look, in 1990 we only had this many, students, and now we have this many students, so we need more facilities or whatever. So in that case, yes, it makes sense to talk about the number of people who are obtaining a certain level of education in absolute terms. But if you're trying to compare sort of the educational makeup of the population, then you got to look at proportions instead. So anyway, that will do it for section 1.2. I hope you enjoyed that and learned something from it, and I will talk to you again soon.